Yesterday I left you with a mystery, probably the most important and difficult to understand mystery of this unit. And a lot of people have gotten back to me and written some theories and ideas, and that's perfect. That's exactly what you should be doing. Uh, but let's investigate a little bit further. How is it that we come across this problem? And let me just quickly recap what it was we were doing so we remember. We knew that our angle was in the third quadrant, and we knew that the sine of the angle was negative 1 over 5. Since sine is y over r, and r must be a positive because it's a radius, that led us to the conclusion that y is equal to negative 1. And we used this idea of the equation of a circle, r squared equals x squared plus y squared, in order to determine that x squared is equal to 24. Now, when you take the square root of 24, your calculator gives you a positive number, 4.8 or 4.9 or whatever it was. However, you knew that when you inverse a squared and take a square root, that there are in fact two answers. There's a positive answer and a negative answer. And we also knew that in this situation, because we were in quadrant 3, and quadrant 3 is down here where your x's are negative and your y's are negative, that we had to choose the negative square root, or the opposite of square root of 24, for our value for x. Now, at that point, we knew three things about theta. We knew that theta, if you took the sine of theta, you get negative 1 over 5, right? So I'm just going to quickly write this again. If we write sine theta is equal to negative 1 over 5, we knew that cos of theta is equal to square root 24 divided by 5, and it has to be negative. And we knew that the tan of theta is equal to 1 over square root 24. And it was positive. Now, when we inversed each of these things, okay, so let's go back to GeoGebra and we'll inverse each of them. So negative 1/5 is the sine, so I go inverse sine of that number, gives me negative 11.54. Okay, now then I inverse the cos, and I get, so negative square root 24 divided by 5. I do inverse cos of that number, I get 168.46. And I inverse tan that, so it was the tan was 1 divided by square root 24, and I inverse tan that number to get 11.54 again. Now, it takes some thinking as to what is going on in each of these questions. And today's lesson is about, and actually what you notice here, right, is that none of them are actually the right answer. The right answer was 191.54, and I got 11.54, negative 11.54, positive 11.54, and 168.46. You may not see it yet, but these are actually all right. They just need to be interpreted. And I say interpreted in the same spirit that we did this operation earlier. When you took the square root of 24, your calculator said, 4.8 whatever, right? Square root 24. My calculator says 4.899. But for some reason, in the question, we did not accept that answer. We took the answer negative 4.899, even though our calculator didn't say that. Now, the same logic is going to apply here. Your calculator is giving you what you need to get the answer, but it can't give you the answer. It can't give you the answer directly. Okay, and we're going to talk about why that is today and hopefully get to the bottom of this. Okay, so I'm going to come back to this, but let's talk a little bit about today's lesson, and then we can come back and answer this question once we know a little bit more. This exercise, it's just asking you to, what is the sine, cosine, tan of each of these values, and then to fill out the table. I think I'll fill out the table, but I don't see why you need to watch me do that. I mean, all I'm going to be doing is just typing in numbers, and I'll have it done so you can check your work, but we'll just come back to it. Okay, now here is the main problem. Okay, viewed again through a different lens. So in this first question, it says the sine of theta is 0.6589. This does not seem like a very difficult question. I go inverse sine of 0.6589, and it gives me the answer of inverse sine. Sorry, was it 6589? Sorry. It gives me 41.216. It says to the nearest degree, but we can just keep it to a more exact value because it'll illustrate a point I'm trying to make. Now, this looks pretty easy. I'm going to quickly draw it. I'm going to draw a point A, which I'm going to call 1, 0, a point O, which is going to go in the middle, and then I'm going to rotate point A 41.216 degrees. And that would be point A prime, which I'm just going to simply rename to point P, just so the way we're used to seeing it. And then I'm going to draw a segment A to O and a segment O to P, as we usually do. I'll just get rid of these labels, and then we'll measure the angle from A to O to P, and we measure that it is 41.216 degrees. And if we take the sine of 41.216 degrees, we get the 6589 that we started with. So it seems pretty easy. All I had to do was inverse sine. I did inverse sine. I got the answer. I drew it, and it's done. Let's just quickly take an image of this. Okay, so there you go. Now, when I go back and read this again, it says use trigonometric ratio to determine all values of theta. Well, what do you mean all values? Why is there more than one value? Right? We found one. And then it says sketch both principal angles. So, wait a second. So there are two answers? Whenever you inverse sine or inverse cos or inverse tan something? How is that possible? Let's go back for a second and think about another angle that would be related. Okay, let's draw a point at -1, 0, and then let's rotate that point. I'm going to rotate it -41.216 degrees so that it rotates. Oh, sorry, you got to put the angle in the middle, and then O at the end. Okay, so that again, we just do the same thing. Angle B prime OB is also 41.216, right? And then I'm going to make another segment, and I'm going to measure another angle from A to O to B prime. I know this is getting a little cramped in there, but let's just look here. And let's hide this and this. Now, what is special about this angle? I'm in quadrant 2. In quadrant 2, sine is positive. If I check the sine of 138.784 degrees, I get 0.6589, exactly the same as what my question was asking. So I posed this question to you at the very beginning of this unit, and I said it would come back and it would be a challenge for us, because it is a challenge to just understand what is going on here. Okay, the fact is that there are two angles that have this sign. One of them's in quadrant 1, one of them's in quadrant 2. They have the same beta, of 41.216 degrees. Okay, so this is what is why the calculator is giving us weird answers. Let's go back up here for a second. I'm going to draw these three things and you're going to see what the calculator is trying to tell you. So let's draw the three things the calculator is telling us in the question we were doing. Okay, now we know, let's just see here. So according to sine, I'm going to call this point S. We're supposed to rotate point A negative 11.54 degrees. Okay, so it's supposed to go down there. According to tan, we're supposed to rotate it, so I'm going to call it T. We're supposed to rotate A 11.54 degrees up there. According to cos, we're supposed to rotate it 168.46 degrees. Now, what do you notice about the three things that have been drawn here? If I draw a circle with radius 1, okay, all three of these things that it just asked me to do have something in common, right? They all have the same beta. They all have the same beta. Let's measure the beta for each one, okay? The beta on the left side, so let's just draw another point, b equals negative 1, 0. And then we're going to go angle COB is 11.54. You may not have noticed that the answer cos was giving you was exactly 11.54 away from 180. It was trying to tell you the beta, right? It wasn't trying to tell you the answer, it was trying to tell you the beta. So let's rename this to beta from cosine. The beta from cosine was telling us was 11.54. Now the beta from the other two obviously is going to be the same because that's what they actually were, but let's just demonstrate it. So beta from sine was telling us angle AOT, AOS, sorry, and it should be SOA, sorry, right? Was also 11.54, and the beta from tan was the angle from A to O to T, and that was also 11.54. So now we understand what the calculator is doing. The calculator is not trying to tell you theta. Cannot tell you theta, directly all the time. Instead, it gives you information about beta and trusts you to put it in the right quadrant. Now, how do you know what to do, how to put it in the right quadrant? This question, if you recall, said that the angle has to be in quadrant 3, which means what I need to do is take my answer, 11.54 degrees, and simply move it into quadrant 3. How do you move something into quadrant 3? You do 180 to get you over to here, and then you add beta. And that's what I did. And I get 191.54, which you notice is the exact answer that I was looking for. So the reason that this is difficult is because more than one angle has the same sine. Sine 41.216 is the exact same thing as sine 138.784. They both have a sine of 0.6589. So which one do you mean if you tell me that the sine of theta is 6589? Do you mean the one in quadrant 1 or the one in quadrant 2? Because this question does not specify which one I actually need, and it actually tells me to get both, that's what I'm doing here. I'm getting both answers. Okay? So, again, this is a big concept. I just, I tried to just go through it and explain it, but this is going to take you some time to digest and think through. the first thing to grasp is that your calculator is not going to be able to tell you theta when you inverse sine or inverse cos or inverse tan. Okay? It is going to be able, but it is going to be able to tell you beta. Your job is to place beta into the correct quadrant. Okay? Let's quickly review how do you get beta into the right quadrant. Okay? Let's just do a quick example here. So I'm going to create a circle. So let's make a 1, 0. Make a circle of radius 1. And then what I'm going to do is I'm going to make a slider called beta. I'm going to make it an angle called beta. It's an angle. Beta can never be bigger than 90 anyway, because it's the. And then what I'm going to do is rotate a beta. Okay. Now I'm going to reflect a prime across y equals 0. I'm going to reflect a prime across x equals 0, and I'm going to reflect a prime across one of those reflections. Reflect. Oh, I see. No, sorry, I'm doing this wrong. Okay, sorry. Reflect a prime y equals 0 across the line x equals 0. Okay? Now, all of these things, okay, let's just draw a quick segment. So O, segment O, A prime, segment O, A double prime, segment O, A triple prime. Oh, A double prime 1 is what it called it. Okay, and then segment O to B. And let's hide all of these for a sec. So draw this diagram. Okay, you have to have this diagram somewhere. Just draw a circle with 4 lines on it. You don't need the points. It doesn't matter. Okay, and your beta, you can see beta sort of controls the angle with the x-axis. So let's write down how to get beta in each quadrant. In the first quadrant, beta is simply equal to theta. The first quadrant is the easiest, and that's why you learned it in grade 10, because you never needed to worry about this really in grade 10 because you're always working with less than 90 degrees, except for the cosine law, and we'll talk later about why it doesn't matter when you're using the cosine law. In the second quadrant, theta is equal to 180 minus beta. That's your quadrant 2 formula. That's how you move an angle into quadrant 2. Take the beta and move it into quadrant 2 by subtracting it from 180, right? So again, if beta's 30 here, then the big angle would be from A to O to here, and the big angle would be 150, which I get by taking 180 and subtracting the beta, right? So again, let's hide this, but let's rename this one too so quickly. So in quadrant 1, it's obviously the easiest. Quadrant 1, your calculator just tells you the answer. In quadrant 2, your calculator will tell you how to get the answer, but it may not be able to tell you directly. In quadrant 3, your theta is equal to 180 plus beta. Okay? Quadrant 3. I'm just going to zoom this out a bit, put it out here so it's not so. Okay, and let's get rid of the axis in the grid here first. Sorry, we need the axis. Okay, and finally, in quadrant 4, theta is equal to 360 minus minus beta. Okay, so this is how you're going to move things from quadrant to quadrant. Okay, whenever you need to. If you know the beta, you can tell me the answer in whatever quadrant you want by simply using this formula to move it around. I'm going to paste this formula, this set of formulas right here. So it's just at the beginning of the lesson so you can see it. Let's go back to what we know now. When I inverse sine this question, a better way to think about the answer is, instead of jumping to the conclusion that theta equals 41.216 degrees. Instead of doing that, what I suggest you do is you instead write, so let's strike that through. Let's instead write the idea that beta, okay, oh right, beta is 41.216. Then I can ask myself the question, where is sine positive? Because in my question, sine was positive. So I ask myself, where is sine positive? According to the cast rule, sine is positive in quadrant 1 and quadrant 2. So my first answer is a really easy one. Theta equals beta. Oops, beta. So that's easy. So my first answer is theta equals 41.216 degrees. Got it. That's the quadrant 1 answer. So that's the Q1 answer. So the Q1 theta would be there. Now the Q2 answer. In quadrant 2, okay, theta is equal to 180 degrees subtract beta. And the reason for that is, again, 180 would get you all the way to the other side, and then you would back up beta degrees in order to get your theta. So the Q2 answer is theta is equal to 180 minus 41.26, which is 138 point, what is this, 7, what did I wrote it down here, 784. Okay, so those are your two answers. Okay, now let me just, one last time, we'll just draw this one last time and measure them and show that it's the same. So A is 1, 0, 1, 0, O is 0, 0, and rotate A 131.78, was it 784? 784, 138.784. 38.784, okay? Now, when I draw a segment from O to A and a segment from O to A prime, I'll just get rid of these labels, and then we're going to measure the angle, AO, A prime, and then we're going to do sine of alpha, and it is exactly what the question said, 6589. So this is another answer, okay, which is just as useful and just as correct as the ultimate answer, as the first answer was. So it could be 41.216, it could be 138.784. There's no way to know. Just like when you square root, there's no way to know if it's the positive square root or the negative. Okay? So this is why it's saying sketch both principal angles. Let's apply the same thing. Now that we've understood the concept, let's apply the same thing to the next question and just see how this is a little, it can be done quite a bit quicker than obviously going through all of that. Let's answer this next one. Cos theta is equal to negative 0.2589. Now immediately, I say the cast rule. Cos is less than 0, so cos is negative in Q2 and in Q3. So I know I'm looking for two answers. I'm looking for an answer in quadrant 2, and I'm looking for an answer in quadrant 3. Okay? Now, so let's do the same thing we did for sine. When I try to do, now, yeah, again, this is kind of unfortunate. I wish I was doing one that wasn't cos to show you something different, but you know what? I actually do think that that's worth it. Let's just change this to tan, okay? Because cos has an additional layer of difficulty to it that let's just come back to cos. We will do it, but just not right now. Okay? So let's talk about tan. So let's say tan is negative 2589. And the cast rule says, where is tan negative? Tan's negative in quadrant 2 and in quadrant 4. So those are the two places tan is negative, right? So let's go, okay, so what do? I inverse tan negative 0.2589. What happens when I do that? Now, when you inverse tan something, I can just go back to here, actually. And I'm just going to type, how much, sorry, I see. Okay, so sorry, inverse tan negative 2589. Okay, so let's go back here. So inverse tan negative negative 0.2589. Now, it gives me this number, negative 14.515. Okay? Now, here's where I gotta try to explain something about how inverse sine, cosine, tan work. I'm going to make a little table. When you inverse sine something, when you inverse cos something, when you inverse tan something. Okay? Actually, sorry, there's a better way to organize this. I'm sorry, I should have thought about this before I did this. So here, let's put it here, here, and just insert a row above. Right. Okay, so let's say action, positive or negative. Okay, if you inverse sine a positive number, okay, so think back to what we did up here. If you inverse sine a positive number, you get, it just tells you beta. So that's straightforward. If you inverse sine a positive number, so inverse sine, let's just write inverse sine a positive number, the answer it tells you is beta, which is super. That makes it easy because then we know what beta is. When you inverse cos a positive number, it gives you beta, which again, nice and easy. When you inverse tan a positive number, it gives you beta. So far so good. At least, it may not be able to give us the quadrant that we're supposed to look in, but it can tell us beta, and we can easily move beta into whatever quadrant we need fairly straightforwardly. But what happens if you inverse sine, cos, or tan a negative number instead? So as you saw, when we inverse tanned this number here, it gave me a negative. What is this 14.515? This is negative beta. It's not telling me beta, it's telling me negative beta. If you inverse sine a negative, it also tells you negative beta. So just again, to go back up to the question we were doing yesterday, do you see I inverse signed a negative number? And it gave me beta, but it gave me beta with a negative sign. I inverse tanned a positive number, and it gave me beta directly. Now I inverse cosed a negative, and it gave me something strange. It gave me 180 minus beta, right? And that's the one thing that's the sort of last piece of what is really challenging about this unit, is just remembering that cos works a bit differently. Okay, if you inverse cos a negative number, it's going to tell you 180 minus beta. Okay, this chart here is hugely important. It will help you understand what your calculator is trying to tell you. Okay, so look at my question again. I inverse tanned something. It gave me negative 14.515. I come to the conclusion that beta is 14.515. Okay, beta is the positive version of that number. Now, I know that there are two answers for tan. There's a quadrant 2 answer, in which theta is equal to 180 degrees minus beta. There is also a quadrant 4 answer, in which theta is equal to 360 degrees minus beta. Okay, so my quadrant 2 answer is just going to be 180 minus 14.515. So let's go back to the worksheet I was working on. So I'm going to do 180 degrees minus beta. It gives me, oh, I'm sorry, I forgot to change beta to a positive because I'll explain why it's giving a negative, but let me just quickly do this. So I'm just going to rename this to calc. This is what the calculator gave me. I know that beta is the absolute value of what the calculator gave me, the positive, and then this is 180 minus the beta. Okay, so 165.4848. Okay, is my quadrant 2 answer. Now my quadrant 4 answer, right, Okay, quadrant 4 answer would be 360 minus beta. So I go 360 minus beta, 345.4848. Now, how can I check if this is right? I can check if this is right by saying, sorry, let's type this out right first. Okay, I can check if this is right by actually checking the tan of these two angles, right? And making sure that they're negative 2589. So watch, I go tan of gamma is negative 2589, and then I do tan of, I think that's sigma? No. Which one is that? I don't know. Let's just rename it to, oops. We'll rename it to P, whatever. Okay, so if I do the tan of P, it also gives me negative 2589, exactly what my question asked for. So to give my answer, there are two angles which have a tan of negative 0.2589, and they are 165.4848 and 345.4848. Okay? I'm not going to draw them just to save us some time, but you can sketch them. All you do is sketch it in quadrant 2 and quadrant 4 with the correct beta of about 15 degrees. Now, this next one, it says cosecant theta is negative 2158. Okay? And, yeah, I think we have another. Do we do another one with? I'll change the last one to cos so that we get to practice a cos, okay? Because this one's otherwise these are going to be the same. So cosecant theta is equal to negative 2.158, which means sine, right? Because cosecant is the same as sine. Cosecant is the reciprocal of sine is 1 over negative 2.158, and that is the same number as negative 0.4634. Okay? So don't be just, if it's cosecant or cotangent or whatever, just flip it over and then you're good to go the same way you would have done any of the other questions. So I know that what I'm going to do here is I'm going to do the inverse sine of negative 0.4634, and when I do that, okay, sorry, it tells me negative 27.6062. Okay? Now, I go back to my chart and I ask myself, what is inverse sine trying to tell me when I inverse sine a negative number? When you inverse sine a negative, it tells you negative beta. So I look at this, I go, okay, I get what my calculator is trying to do here. It's trying to tell me that the beta in my question is 27.6. Let's just round it to 1 so I'm not keeping so many decimals. Now, I also know that sine is negative in quadrant 3 and in quadrant 4. Therefore, I have two answers. I have a quadrant 3 answer, which is 180 degrees plus beta, and I have a quadrant 4 answer, which is 360 degrees minus beta. Okay, and therefore my two answers, so my Q3 answer would be, okay, let's see if I can do this, 152.4 degrees. My Q4 answer, sorry, I had to add it, not subtract it, I apologize, that's wrong. So 180, so this is easier, 207.6 would be one answer, and then in quadrant 4, this would be where I should have kept what I just did, 332.4 degrees. So I write underneath, therefore, there are two angles which have a cosecant of negative 2.158, and those angles are 207.6 and 332.4. Again, there's no reason to give an answer in this unit without knowing it's right. So go ahead, go back to your calculator. I mean, GeoGebra is nice for this because it actually does have a cosecant function. So you take cosecant 207.6, and it gives you, our original answer, negative 2.158. I'm going to double check my other answer. I'm going to type cosecant of 332.4, and it gives me the same thing. So I got the two angles that have that cosecant. Okay? All right, this last one, let's change it to cos because we skipped cos earlier, and I skipped it because cos is a little bit harder than the other two, but it's not much harder. It's just that when you're doing a negative with cos, you have to do a little bit of extra work to get beta. That's all. So let's go back and look at this one with a negative. Now here is let's start with the concept here of cos theta equals x over r. Okay, so we know that. So we know x in this case is negative 12 and r is 13. Okay, now watch when I draw a circle with that information. So let's draw a circle. So we'll say O is 0.0. We'll go circle that starts at O, a center of O with a radius of 13. Okay, now what we know about this circle is that the x coordinate is negative 12. But look at where x equals negative 12 is. Which y are you talking about? Are you talking about the one in quadrant 2, or are you talking about the one in quadrant 3? Right? We don't know. So when you go into this, you go r squared equals x squared plus y squared. 13 squared equals 12 squared plus y squared. 25, if you just subtract them, you get y squared. And therefore y equals plus or minus 5. There are two answers. There's negative 12, negative 12 and 5, and then there's negative 12 and negative 5. And both of these would work because, let's call this, we'll rename this to the Q2 answer, and we'll rename this to the Q3 answer. And we'll say A is the initial arm is at 13.0, and then we'll go angle AOQ2, and then if I take the cos of that angle, it is, the exact same thing as negative 12 over 13, which is what our question asked us. Okay. Now what if I take the angle from A to O to Q3, and then I take the cos of that number? Again, it is the answer I want. So there are two answers. There's an answer in quadrant 3, and there's an answer in quadrant 2. Both of these would fulfill the conditions. Sorry, this one should go beneath, this one should go above. And let's change the color of this one just so that you have some chance of telling them apart. Okay, there are two answers. There are two answers because there are 2 points on the circle when x is negative 12. Y could be up here at 5 or down there at negative 5. Okay, now the nice thing about it, taking it from here, is you just need to solve it once, and then you can get what you need. So it says, in which quadrant could the terminal arm lie? Well, the terminal arm, so let's answer A first. The terminal arm could lie in Q2, x equals negative 12, y equals 5, r equals 13. Or it could lie in Q3, x equals negative 12, y equals negative 5, and r is still 13. Okay? So that's what this part is about. Then it says determine all the possible primary trigonometric ratios for theta. Well, we can't do that unless we know which quadrant it's in. So let's make a table for a couple of possibilities. Let's say case 1, theta is in Q2, and case 2, theta is in Q3. If theta is in Q2, okay, then sine theta is 5 over 13. Okay, cos theta is negative 12 over 13. And tan theta is, what would it be, negative 5 over 12. Okay? So this is what I'm trying to answer what it's asking for question B, right? It's saying, what are the primary trig ratios equal to? Well, we know x, y, and r, so we know all the ratios. We just need to just put them in the correct pattern. Remember, sine is y over r, cos is x over r, tan is y over x. Now, since we do not know which one of these two things we're doing, we have to give the alternative possibility, which is that the answers are actually all in quadrant 3. In quadrant 3, y was negative, right? So sine becomes negative. But because y is negative, both the negative 5 and the negative 12, right? So we get, are both negative, so we can just write 5 over 12 as a positive. Okay? So when it says find the primary trig ratios, since we do not know which quadrant theta is in, we have to give them all for both possibilities. Okay? Then it says evaluate all possible angles of theta. Now, from this point, you could do it using any one of these. Any one of these would work. Okay? Of course, they would all take a slightly different path to get you to the answer, but they would all get you the answer. Let's work with cos, since that's what was in the question. Okay? It doesn't matter, but let's work with cos. So I know that cos is negative 12 over 13. Therefore, I know that the inverse cos of negative 12 over 13 is an important number. So what is the inverse cos of negative 12 over 13? It is 157.38. Now, interestingly, that is one of the answers. That is the quadrant 2 answer. It gave me theta directly. And cos has this unique ability to do that. Only cos can do this. Notice, cosine in quadrant 2 tells you theta directly. Cos is the only cos can do this. So actually it gave me the quadrant 2 answer. Right? It gave me the quadrant 2 answer, which is great. The problem is that a lot of people, they take that, but they forget how to do the quadrant 3 answer. So remember, when you inverse cos a negative number, try to remember that when you inverse cos a negative number, this is what your calculator is doing. Okay, I'm going to just copy this down here because it's so important. It's a very common error here. When you inverse cos a negative number, it's telling you 180 minus beta. So my 157.38 degrees is 180 minus beta. Okay? Now, why do I want to do this if I already know the answer? Is because I want to move the answer into quadrant 3. So if I just rearrange this equation, I get the idea that beta is, let's just use this to do it. So I'm going to go 180 minus gamma 22.6. Let's say 22.62, just for... Okay, now, I have an answer in quadrant 2. That answer is 180 minus beta. Of course, we already know this answer. It's 157.38. I already got that one. My quadrant 3 answer, okay, is 180 degrees plus beta. And my quadrant 3 answer, therefore, is 202.62. And that's the other answer. And that's where this 202.62 is coming from. Okay? So that's, again, really, really difficult concept today. It's, as you do questions, you will get more comfortable with it. But it is difficult to understand. Because instead of doing a square root inverse, where it could be positive and it could be negative, and yeah, I sometimes mess it up, but I do kind of get it. Here, when you inverse, a bunch of different things happen. Sometimes it tells you positive beta. Sometimes it tells you negative beta. Sometimes it tells you 180 minus beta. Okay? Make sure you have this chart nearby when you're working on this unit so that you get the hang of it. Okay? Try these questions. Post them. Right? Go through them. Explain to me what you're doing and where you're getting stuck. I'm happy to try to help you with this. I know this is difficult, but I can't help if you don't reach out. You know what I mean? So make sure if you're trying a question and you get stuck, or I don't know what to do here, or how did you do this, or whatever, ask. It's a really important lesson to be asking questions. Okay. As a final thing here, it just says it just reminds you that there are more than one answer. Many times in this unit, there's more than one answer that fits, and so you have to be aware of how to get the alternate answers. Remember, everything you do can be checked. It isn't that hard to check. You just take your final answers and plug them back into COAS and show that they give you this number. Okay, I'm going to stop it there. And again, important day to ask questions, so go ahead.